Hi, I'm Amy. I'm a maths tutor and I've been tutoring for over 6 years. I'm studying my Masters of Teaching, so I completed my LANTITE, both literacy and numeracy last year in 2023. I'm just going to be talking through the September 2023 practice questions. They do provide the answers on this website. However, I'll just talk through them if it's any benefit to you. So you can access this on the LANTITE website. And in this little book, there is 20 practice questions, and the actual numeracy test will have 65 practice questions. For section 1, you're allowed a calculator. Now, normally you use the on-screen calculator with a blue button that looks like this. Now, for our case now, and just like the practice questions, I'm just going to be using this one. You're allowed scrap paper as well if you need workings out, but I'll just annotate them on this OneNote. So the first question, I'm just going to go straight past the question, read the actual question stated, and then go back. I do this for every single question. Works for me. It might not work for you, but there's a strategy. So question 1, for how many of the 11 years was the value of $1 Australian greater than $1 US at both the start and the end of the year? So I'm just going to be using, looking at, so $1 Australian greater than $1 US at both the start and the end. So I'm going to go up and look for, I've got the year start and the year end. When $1 Australian is like greater than $1 US, it has to be 1 point something. So not a number lower than 1. Now this is just scanning down. We've only got these two at the bottom that are greater than 1. And then also at the end of the year, we have this one here. So actually the only option that we have going is 2012. So that's just 1 year, meaning that 1 is our answer. Now, question 2, in which one of these years did the value of $1 Australian in US dollars show the greatest change between year high and year low? So we have 4 different options: 2012, 2013, 2020, and 2022. So I'm going to go up and look at these ones. 2012, 2013, 2020, and 2022. Save your time. Make sure you look at those options A to D, not doing all of them. Okay, so we have a year high, so 0.76 take 0.62. I did it just before, so 0.14 is our answer if you just input that. Then you've got 0.77 take 0.57. That's 0.20. Now looking at 2013, we're just going to do 1.06 take 0.89, which gives you 0.17. And 1.08 take 0.97, which gives you 0.11. Now the highest of those is going to be 2020 with a 0.2. So our answer, 2020. Now looking at the next question, question 3, below are some combinations of floor and window dimensions. Does each combination meet the guideline? Now we need to go back up and read the guideline, and we're just going to select yes or no. So in one Australian jurisdiction, a guideline for planning childcare centres concerns the provision of natural light. Childcare centres should have a total window area of not less than 10%. So that's of importance to us, of the floor area of the room. Now, area, it indicates to me that we're going to have to calculate. Area is the length by the width. And to find percent, not less than 10%. So it can't be less than 10%, it has to be more. To be able to calculate percentage, we're going to need the value over the total multiplied by 100 to get the percentage. Okay, so select yes or no. I'm going to look at this one. We have a window 3 by 2 meters, meaning that our area is 6 meters squared, and the floor 7 by 9, we're going to have 63 meters squared. To find the percentage of this, we put 6 because that's the window, over 63, and we multiply that by 100. You're going to need the calculator for that. So 6 over 63 by 100. Here we have 9.5%. Now that's less, so it does not comply. We do the same. 4 windows, each 1 by 2. So it says total window area. If there's 4 windows, we add them all together. So 1 by 2 is going to be 2 meters squared, and we multiply that by 4 because there's 4 windows. So we have 8 meters squared, and the floor is 8 by 8, so 64 meters squared. Now to find the percentage, we have the value, which is 8 over the total, total of the floor, which is 64, times by 100 is equal to 12.5%. Now that's greater than 10, so yes, it complies. I just wanted to draw attention to one thing. This is typically how you find a percentage. However, with this question, we're going to do the percentage of the window over the floor because it's what it's asking in the question. So that's the only difference there, and multiply it by 100 if you're confused. Okay, the next is on a planter box, question 4. The store also sells 50-litre bags of soil. 50 litres is equivalent to 0.05 meters cubed in volume. That's important. How many bags of soil are required to fill 1 planter box? So how many bags of soil? The first part is kind of just irrelevant now. Now, it's kind of indicating that we need to find the volume, and it's got the picture there. So volume is just going to be length times width times height. So we've got 2.4 times 1 times height 0.5. So on the calculator, you've got 1.2, and that's in meters cubed. Now we've got 1.2 meters cubed of the planter box, but we need to find out how many bags of soil can fit in there. So what we're going to do is we're going to do 1.2 meters cubed divided by 0.05 meters cubed. And that's going to tell us how many different bags can fit in there. So on the calculator, again, we're allowed to do that. It gives us 24 exactly. So that's a nice answer. We don't have to worry about anything else. 24. The next question we have is on STEM confidence. I'll skim past this and read the question. Question 5. Below are some statements about the graph. Select true, false, or unable to determine for each statement. The STEM subject with the lowest percentage of students who reported they are somewhat confident or very confident was engineering. So the lowest percentage, somewhat confident or very confident. If I go up, immediately I see somewhat confident and very confident. So it's like the darker colors kind of over this end here. We're looking at engineering, so I'm just going to keep kind of this section here we're looking at. Now, if you compare that to everything else, 39, 23, 41, 23, 39, 23. Right, and then for engineering, it's quite low. We've got 27 and 10. So yes, that there is true. More than 100 students reported that were not confident or at all in technology. So we're going to look at technology And we're going to look at not confident at all. Not confident at all is here, 4%, but we don't actually know, or actually 2,000 students. So there's 2,000 students surveyed in this. Okay, so 4% of 2,000 students. To be able to find what 4% of 2,000 students is, you convert it to a decimal. Converting 4% to a decimal, what we do is we divide by 100, which makes 0.04%. Now, oh, sorry, not percent, 0.04. So we have 0.04 and we multiply that by 2,000. So that's how many students there are. Now that will give us the percentage of students who have voted for not confident at all. So that's given us 80 students. Now the question says more than 100 students, so that there is false because we only have 80. The students who reported they were very confident in science were the same students who reported they were very confident in technology and very confident in maths. In a survey, how are you supposed to know who's very like, you have no idea what students have selected in what categories based on this data. So straight away, I can just say that's unable to determine. Now, the next question looks on student data, and as always, I'm going to read the question first. Students who score 15 or less will be part of a targeted teaching program. What percentage of the group of students will be part of the targeted teaching program? This is where my percentage that I explained before, it comes in handy. So it's going to be the value over the total multiplied by 100. So that value there is going to be students who get below 15. And the total is going to be the total number of students. So that's quite easy there. Now we're going to go up and we're going to see who scores 15 or less. Okay, so 15 or less. Raw score, we're going to look at less than 5, 6 to 10, and here 11 to 15. Who score 15 or less, so it's 15 inclusive, which is good. We don't have to discount anything. So we just add the number of students, 2 plus 4 plus 8. Now that there is going to give us 14. So our value for the students under 15 as a score is 14. And the total number of students, it says at the bottom there, 50. And we multiply that by 100. And that gives us 28%. All right, the next question is quite application-based, paying for dinner, somewhat relevant to your life. Question 7, Kim pays for both dinners with a $50 note. How much change should Kim receive? So she's paying for both. Kim has a burger for $15.90, Lee has a salad for $14.90. They have a drink and each drink costs $4. So given that they have 2 drinks there, that this is the part that's going to trick you, you need to multiply that by 2, which is equal to 8. So if we're adding all of these together, we've got 8 plus $15.90 plus $14.90, and that is the total for their dinner. So just do that on the calculator. And you're left with 38.8. So $38.80 pretty much. Now she pays with a $50 note. So if you're paying with a $50 note and your dinner costs $38.80, I'm going to do subtraction like this. Just put it in the calculator and you'll have your answer of $11.20. All right. Next question's based on a field trip. It looks like a map here. Question 8, the direction of north is shown on the map. which of the following directions is closest to the direction of the sign from the bench? So of the sign from the bench, you start at the bench and you look towards the sign. That line was really bad. More like this, okay? That north sign is going left here. Now, what I would recommend is just kind of drawing the rest of it quite big. So if north is this way, east, south, west. Never eat soggy wheat bix. That's how I remember it. Now, if that arrow is kind of going up like this, I would say it's more east, south, southeast, pretty much. So our answer is southeast there. Question 9, which of the following is the shortest roll of ribbon that the teacher requires? So she wants to make 80 ribbons and each is 12 centimeters long. So to be able to make that work or figure it out, we have 12 centimeters multiplied by 80, and that's going to give us the total amount of centimeters of ribbon that we require, which is 960 centimeters. Now, to convert from centimeters to meters, we divide by 100 because there's 100 centimeters in 1 meter. And dividing by 100 is going to give you 9.6 meters. So the shortest roll, if we're looking, well, no, we can't do 1 meter or 7 meters. The shortest is going to be a 10-meter roll.